Algebra 2 honors, we're doing solving trig equations, and we're going to add some more techniques on this, and it's also a review for the upcoming test. And so you're going to solve equations, so there's a little bit more to these than what we've been looking at before. And so I'm going to do the first column, and you need to fill those out as I do them, and then you need to complete by filling out the second column on these. And so in number 1, the first thing is to isolate the trig function, so subtract 2, and you want to know where sine of x is 1. Well, this is to be done with no calculator, and on the unit circle, the sine is the y coordinate, and so you're looking on the unit circle, where is sine 1? You can also think graphically of where does sine hit 1, because you should know the basic footprint of sine, and so where is y1? It's a quadrantal angle, and it is pi halves. And so your solutions from 0 to 2 pi. Now, note this includes 2 pi, unlike the first worksheet that I did like this. But in this one, your answer is, what is that angle? It is pi halves. Number 2, solve for the trig function. So move the 8 to the other side. Divide by 4, and we want to know where secant of x is negative 1/2, which is going to be the same as its reciprocal function cosine being, negative 8 divided by 4 is negative 2. So secant of x being negative 2. Well, it's the reciprocal of cosine, so we're really looking for where cosine is negative 1/2. And cosine is negative in quadrants 2 and 3. So we're looking for a quadrant 2 and a quadrant 3 angle where the cosine is negative 1/2. And those angles are here at 2 pi thirds and here at 4 pi thirds. So your answers to that are x is 2 pi thirds and 4 pi thirds. All right, number 3. Again, isolate the cosine function. Divide by 18. And that simplifies to root 3 over 2. And so on the unit circle, you want to know where cosine is root 3 over 2. By the way, the other thing that you should know is if we use the hypotenuse of 1 and a 30, 60, 90, you are looking at for which reference angle is cosine going to be root 3 over 2, adjacent over hypotenuse, and it's 30. So that's going to be pi 6. And then you're to know that cosine is positive in quadrant 1 and quadrant 4. So I'm looking for 30-degree reference angles in quadrant 1 and in quadrant 4. So get rid of the ones from the last one. And so again, where is the x-coordinate root 3 over 2? For what angles? And those are pi 6 and 11 pi 6. Because the idea is that you shouldn't actually need to look at a unit circle at all to get these. So you need to memorize or have some processes to help you get there. Okay, so now we're going to add a square root method. So we're going to start on number 7 to solve for secant. So we're going to move 1 to the other side, and then when I take the square root of both sides, I need to remember I need plus or minus the square root of 1, which is 1. So you just took the square root of both sides, but when you do that, you need plus or minus. And so I need to know where the secant is 1 and where it is negative 1. And that's going to be the same places where its reciprocal function cosine is 1 or negative 1. And those are those quadrantal angles where the x value is 1 or negative 1 on the unit circle. And so the angles that make that happen in radians, 0, pi, and this includes 2 pi, so I have to use when I go a full rotation around and include 2 pi. And those are the angles where the secant will be plus or minus 1. Number 8, solve for cosine. So start by dividing by 2 And then we are going to take the square root of both sides, but remember you need plus or minus, and I get cosine of x is plus or minus the square root of 1 over 2, which is the same as the square root of the numerator over the square root of the denominator. And if I remember, this is going to be those ordered pairs, root 2 over 2. If I rationalize 1 over root 2, I've got plus or minus root 2 over 2. So these are all your 45-degree reference angles. That's where you're going to get x values that are positive root 2 over 2 and negative root 2 over 2. So you have one in quadrant 1, in quadrant 2, in quadrant 3, and in quadrant 4. Number 9, solve for tangent. So start by adding 9 to the other side, divide by 3. And then take the square root of both sides and you get plus or minus. So I want all the places where tangent of x is plus or minus the square root of 3. And you need to remember that tangent is y over x. So what ordered pair gives you where you have root 3 over 2? Well, it's where you have root 3 over 2 over 1/2. That's where you get that value of root 3. So you want all ordered pairs where x is 1/2 and y is root 3 over 2. Excuse me, and that's both positive and negative. Sorry. And those are your 60-degree reference angles. That's where you go short 1/2 and up long of 1/2, or to the left. There we go. So to the right 1/2, up root 3 over 2 is going to be root 3 over 2 over 1/2. That's going to be root 3, or to the left, negative 1/2. Oops. Negative 1/2 up root 3 over 2 will give you your negative root 3, or 60-degree reference, or pi thirds in quadrant 3 and in quadrant 4. Those are going to be giving you those. I'm right at the bottom of the page. It doesn't like to stay there for me. So we've got negative 1/2 negative root 3 over 2 and positive 1/2 negative root 3 over 2. And all of those y over x are going to simplify to root 3 positive or negative. So those are all my angles. And so 60-degree reference, but in radians, pi thirds, 2 pi thirds, 4 pi thirds, and 5 pi thirds. Again, no calculator. You need to be able to solve these and quickly, and you've got to practice it to get there. Now, here's another technique, solving by factoring. And so I'm going to see this as an s squared minus 3s plus 2 and think about factoring. But I really don't want your final presentation of your work like this. It's x squared minus 3x plus 2 equals 0. We're factoring. So I need things that are going to multiply to be a positive 2 but add up to a negative 3, which is a minus 1 and a minus 2. But now I want it done with the full sine cosine expression. So this is kind of like your scratch work off to the side, not your formal presentation. And so this is going to be a sine x to begin with and a sine x to begin with. So sine times sine is sine squared. And things that multiply to be negative 2 but add up to negative 3 are going to be a minus 1 and a minus 2. And then we're using the zero product principle, that if two things, so we have two quantities here being multiplied to be 0, the only way they can be 0 is if one or the other is 0. So I have, and I want to see this work, sine of x minus 1 equals 0, or sine x minus 2 equals 0, and we get sine of x equals 1 or sine of x equals 2. I'm going to start with that sine of x equals 2. If I think of the graph y equals sine of x, it starts at 0, goes up to 1, down to negative 1. Sorry, that's not quite as good as I would have liked to. So it's going by pi halves. Goes 0 to 1 to 0 to negative 1 to 2 pi. And you should know that basic footprint of sine just that quickly. Well, there is no angle. I'm looking at all these angles from 0 to 2 pi. There's not one that produces a y value of 2 because the range of sine is -1 to 1. So an angle whose sine is 2 is not possible. That won't lead to any solutions. However, where is sine of x1? That's one of those quadrantal angles. Or if I look at the graph, it's at pi halves. Again, it's here at 0, 1, where your x value is 0, your y value is 1, your r value is 1, and sine of pi halves is y over r, or it's just the y value on the unit circle. It's 1 over 1, and it's 1. So what angle between 0 and 2 pi is the sine going to be 1? It is going to be at pi halves. You want to have some flexibility. You want some other ways to think about solving these. All right, now this next one is a commonly missed problem because people want to divide by cosine on both sides and they lose solutions. You need to, on this one, move that cosine of x to the left and set this equal to 0. And then these two terms have a common factor of cosine x. I'm going to pull out the cosine x. And that leaves me with sine squared of x. And be careful, when I pull out cosine, I'm dividing by cosine. This is a 1. So look at that factoring. Oops. If I redistribute the cosine x across both terms, I end up with the line before. That's important. Now we have that zero product. If you have two things being multiplied that multiply to be 0, one or the other must be 0. So we need all places where cosine is 0, and that's where on those are quadrantal angles. I can also think about the graph of cosine starts at 1, pi halves is at 0, and at pi you're at -1, 3 pi halves you're at 0, and at 2 pi, I can think about the graph where you get to 2 pi. That can tell me pi halves and 3 pi halves. But it's also a quadrantal angle where the x-coordinate is 0 on the unit circle. There's another way to think about it. So the solutions to these are pi halves and 3 pi halves. That's just for the cosine of x being 0. Now sine squared of x being negative, or we need to solve for sine here. Add 1, take the square root of both sides, and when you do that, don't forget you need plus or minus. And I need all the places where sine is plus or minus 1. So up here I had y equals the cosine graph. Here I could think about this graph of sine of x, which you need to just know. Starts at 0, pi halves is up at 1, and then at pi we're at 0, 3 pi halves we're at -1. And then at 2 pi you're back at 0. So if I have that graph of sine, it is 1 at pi halves and it is -1 at 3 pi halves. Think of it graphically, or think about on the unit circle, it is the y values on the unit circle, and at pi halves sine is +1, at 3 pi halves sine is -1, and so you get the exact same solutions. That doesn't always happen, by the way, but overall your end answer, we don't repeat them again, it's just a pi halves and a 3 pi halves. It just happened that both of those had the same answer. But that's that technique where you got to move it to one side, don't divide by it, you'll lose solutions. Usually, this case you might not have, but if you show the wrong work, you won't get full credit. So, using factoring. Okay, so this next one, I have a cosine squared and a cosine equals 0. It's already equal to 0, and I can factor out a cosine of x. So, as you factor it out, you're dividing each term by cosine. Think about if I redistribute, cosine times cosine is cosine squared, and then distribute a -3 times cosine is that -3 cosine x. So if I redistribute, I'd be back at the original line. So these are the same thing. Now I have two things that I'm multiplying to be 0. Zero product principle says then one or the other has to be 0. So again, here I want where cosine of x is 0, which we just described in the last problem. It's when on the unit circle the x-coordinate is 0, which happens at the angles pi halves and 3 pi halves for cosine. And this other one, if I solve, add root 3, divide by 2, I need all the places where cosine is root 3 over 2. Well, cosine is your x value in the unit circle, and I need all places where the x value is a positive root 3 over 2, which is in quadrant 1 and in quadrant 4, and it's going to be your 30-degree reference angles. So if I think on the unit circle here, at pi 6, I have root 3 over 2 up one half, or 30-degree reference angle, I have root 3 over 2 minus 1/2 in quadrant 4. Now what are those angles? Oops. They are going, if I can get this to stay, x is pi 6, or x is 11 pi 6. It is that 30-degree reference angle. So you need all 4 of those, pi halves, 3 pi halves, pi 6, and 11 pi 6 for solving those. 16? You need this equal to 0 to have that, be able to use that zero product principle. So the first thing is to subtract over the 1, set equal to 0. And then we need to factor. You need to think of this as a 2s squared plus s minus 1 equals 0, or 2x squared plus x minus 1 equals 0. Again, if you do this stuff, do it off to the side and then go back and change it out for the correct trig functions directly below the problem. And so you need to figure out, okay, if I need 2x squared, so I need a 2x and an x. But I need to multiply, so the end answer is -1, but they add up to be positive 1x. And a 2x and a minus x does that. So now it wasn't x, these are trig functions. So I need to use a 2 sine x and a 1 sine x, so that if I multiply those, I get 2 sine squared x. And then I need the plus 1 with the sine x, oops, and the minus, I'm at the bottom here, I'm resting my hand, it jumps. There we go. If I FOIL that out, I'm going to get a positive 2 sine x and a minus 1 sine x in the middle, which is that plus sine x in the middle. And that equals 0. Don't forget the equals 0. So now two quantities multiply to be 0. One or the other must be 0 for that product to be 0. So solve for sine x in both of those. And then think about on the unit circle, where is the y-coordinate 1/2? Well, sine is positive in quadrants 1 and 2 because y is positive in quadrants 1 and 2. And the angles where sine, the y-coordinate is 1/2, is at pi 6. And then over at 5 pi 6, that y-coordinate is 1/2. And so the solutions are pi 6 and 5 pi 6 for this first equation. Then I need where is sine of x -1. Again, sometimes I think about that graphically. Going by pi halves, the period is 2 pi. It hasn't had any horizontal stretch or shrinks. You start at 0 for sine, you go up to 1 at pi halves, 0 at pi, 3 pi halves -1, and back at 2 pi. So sine hits -1 only one time. The other way to think about it, again, you should know it's a quadrantal angle, and we're looking on the 0, or on the unit circle where the y-coordinate is -1. What is that angle? It is 3 pi halves, which is the same as this x-coordinate here in terms of the graphing of sine. So those are your solutions. You need all of them. So you go back and work on the factoring techniques and the unit circle values and do all the problems in the right-hand column on each page.